Hi guys, Shouvik here. Welcome back to YouTube channel. So today we solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems, snakes and ladders. Yeah, so on this problem statement, they have given us an n cross n integer matrix board where the cells are labeled from 1 to n square in a Brewstropian style. So if you don't know about Brewstropian styles, that is kind of like zigzag kind of things that actually the board is going to be made. Starting from the bottom left of the board, that is board of n minus 1 to 0. So that is the bottom left cells and alternating directions on each row. So let me just quickly give you a gist how actually a Brewstropian styles is actually looks like. But if you, I think we all played snakes ladders game in our childhood, so you should be aware of this. But if not, then I am going to give you a high level understanding of how actually. So let's suppose we definitely have a grid. We definitely had a grid. So let's suppose this is our grid. So in Brewstropians, so this is the row numbers from 0. Row is going to start from 0 to dot 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 dot. So that is of n minus 1th row. And if I am going to mark the columns, that is 0 to dot 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 dot. This is the n minus 1th column, right? In Brewstropian styles, so you should start from this row and can traverse, like this row is 1, then 2, then 3, then up 4, 5, 6, then up 7, 8, 9. So the things is you numbers are going to be increased this like zigzag. So that is the Brewstropian's style of a grid representation. So they have given us a Brewstropian's grid altogether. Now choose a destination square. Now you start on square 1 of the board. In each move, starting from the square current, do the followings. So what we can do: choose a destination square next with labels in the range of current plus 1 to minimum of current plus 6 and n square. So that is simple Ludo. If you have played, then you are going to get it. So what they are basically asked here, this choice simulates the results of standard 6-sided dice roll. So we can roll a dice, that is there are always at most 6 destinations regardless of the size of the board. So what we can do, what they have asked for. So let's suppose you are standing at this particular 2 number cells, right? So from here and you have a dice and you have a dice, right? You have this dice. So this dice has numbers written from it 1 to 6. It numbers from 1 to 6, like 1, 2, 3, 4, 5, 6. All the numbers this dice is holding. This dice is holding, right? So now what you can do, you can roll the dice and it will give you an arbitrary number in the range of 1 to 6. So that means if you are standing on at this particular cells, what all the options you have at, you can go from 1 cell apart, 2 cell apart, 3 cell apart, 4 cell apart, 5 cell apart, and 6 cell apart at max. So if you are able to generate a 6, if you are super lucky, then you are going to generate a 6. So from 2 you are directly going to 8, right? Else what is the move? Like if your rollout is coming as a 2, then you are allowed to make 2 jumps. So from 2, 3, and 4. So you are going to land here. But if it is like 3, then you are going to land here, and if it is 6, then you are going to land here, like this. Very straightforward. I think you definitely play a Ludo before solving these problems, so that is kind of a must have. Then you will going to get the good gist of this particular problems. If next has a snake or ladder, now the game is not that much simple. So there on the arbitrary cells, there are 2 things can be there. So there can be a snake or there can be a ladder. So snake is basically bite you, and you are, if there is a snake, then you are going to be moved to the destination cells, and if there is a ladder also, then ladder basically a symbolize of positive. Like if you are standing at, let's suppose n, then you are going to get some more higher value. To n2 greater than n, you are going to get a jump. But if it is a snake, then it is most of the cases from n you are going to get some n minus 1th range. From 1 to n minus 1 you are going to get, like basically fall down. And you must move the destinations of the snake or ladders, otherwise you move to next. The game ends when you reach to the squares n square. So you have started from 1 and you have to reach to the n square cell. You have started from 1, you have to reach to the n square cell. That is the extreme, either like on from very bottom row you are starting to the top row, and it can be like first columns or it can be the last column, because it is a Brewstropian's representation, right? So if our board is like odd length, then your game is going to be end to be right, top right corner. And if it is a like even length board, then like n is even, then it is going to be ended on top left. I think it's very straightforward. If you are not going to get it, what I have to just draw some n equals to odd length board and n equals to even length board. You will definitely get it. Now a board square on a row and columns C has a snake or ladders if board of RC not equals to -1. The destinations of the snake or ladders is board of RC. So they have basically already given you a board where board of RC representing if there is a snake or ladder. If -1 means there is no snake or ladder, but if it is not -1, then from that particular row column you are allowed to make a jump. You are not allowed actually. You are bound to make a jump to what is the value written to it. To what is the value written to that particular cells, right? Squares 1 and n square are not the starting points of any snake or ladder. So when you are starting and when you are ending, there is no snake and ladder is altogether present, because otherwise you are getting, right, you maybe like if at a like destinations point you have a snake that is of n square, then you never reach to that particular n square cells, because all the time you are reached on that particular n square cells, the snake bite you and you are fall down to some lesser value of n square. So the game is never ended then. So no one can win on that particular case. So that is not a valid case. So your start and end cell is always holding some value, which is not holding some actually the snake and ladder starting point at least. Now note that you only take a snake or ladder at most once per dice roll. So please take a note on these particular points, because this I missed it to read it properly to this particular line, and for that I need almost 1 hour extra to get the AC. Otherwise I mostly will get the accepted in very first go. I like not focused on this line that much because I already played Ludo on my childhood like rigorously, so I know what is the game is. But on these particular lines it's kind of a haphazard things they have made it. So that particular board is altogether not exist what they are basically trying to make it. So that's the reasons, like it is a kind of like not if these lines is not altogether no man, so then I will definitely suggest it is a good problem. But with these lines it is like unnecessary complicated. They have basically unnecessarily complicated the entire problems. So with this line it is not a medium problem altogether. It is definitely a hard problem. So with these lines like board representation, everything, so what we have played on the childhood is not going to be valid. So it is valid, but there is some extra handlings you have to be taking care of. So that's the reason I not actually too much like this particular problems, but it is indeed a good problems. Like we have to learn like good topics, BFS, DFS, graph traversal algorithms we are going to it. So definitely BFS, I have implemented only BFS, so you will definitely get a good gist on how to apply BFS on a grid related problems. Now, if the destinations to a snake or ladder is the start of the another snake or ladder, you do not follow the subsequent snake or ladder, right? So what they have basically asked for, so they have given an example. For this you will definitely get this. For example, suppose the board is this configurations, and on the first move your destination square is 2, right? So you go to, so that is the bottoms, you are starting from this to this. So you go to this 2x cells and you follow the ladder. So ladder will basically make you to go to 3, that is of this row, right? And you follow the ladders to square 3, but do not follow the subsequent ladders to 4. But do not follow. So if I can draw this -1 4 1 -1 3, right? So our board has -1 4. What else? -1 3, I guess, right? -1 4 -1 3. Stop क्या working? Shit, one note again is going to be die. Can you allow me to write? It is not. Now, yes, it is allowed. So what they have basically looking for, so our number is 1 2 3 4, right? So that is the Bustovian's way of writing 1 2 3 and 4. So we have to reach this particular cell. So and we are going to start from here. So from here, if it is coming out as a 2, so 1 1 2, so you reach to this particular cells. Or I think, sorry, I missed it. So if it is coming to be an 1, right? So you rolled your dice, you rolled your dice, and it is coming to be. So please take a note on these particular points, guys. So that is the like critical point. So if your dice outcome is 1, so that means from here you make a jump to here, right? And from here you are seeing a ladders and you use that ladders to reach that particular cell. So in one move, so from one move from 1 you reach to 3, and on 3 you saw a ladder. So innately you reach to 4 actually. You reach to 4 actually by how many dice rolls? By a single dice rolls. From 1 to 4 you reached to a single dice rolls, because from you come out as a put, that is of 1, and from 1 you make a jump, you reached here and you found the ladders and you used it and go to the cell 3. So we go to the cell 3 actually. So from 1 we go to the cell 3. What is the number written here? The cell number is 3. Now on cell 3 there is a ladder which is basically allowing you to go to 4. So it is kind of something like this. So here is a ladder. So if I can draw it correctly, So there is a ladder something like this, and from here there is a ladder something like this. So you use this ladder and reach this particular cells, and you use these ladders to reach this particular cells, which is our dead end, which is our game winning point. So by single dice, if you are able to reach here, then eventually with using the ladders only you can end the game. So that they don't allow. So then can I write it like on a single move we can jump from 1 to 4? No, that is not allowed. That is not allowed. So if you are going to get a ladders from this particular cells, I have allowed to jump from 1 to 6, like +1 to +6, and minimum of +1 +6 and like n square, whoever is the minimum of those, I will allow to use them. So my for loop should be kind of like for each in range of what is the value I have at. So from that value +1, and what is the endpoint, I know the last one is going to be exclusive, so I have to take +1. So I will write from val +1 to val +7, so that means val +1 to val +6 it is going to be work. And for every of them, if it is if I found altogether a ladder or a snake, then I am allowed to use it. But if it is not, then I will going to take a +1 jump on that particular cell jump. That is also fine. But let's suppose after using a snake and ladder, you reach to a particular cells where also it has a snake, or it has a ladder on that particular cell also. Then can I write it? Then from that particular cell I can reach to another cells which has a snake and ladder, which can be anything. So am I allowed to do so? So that means from that val cell, I am taking a jump of some +1 to +7s, and I reach to a particular cells which actually have a snake and ladder, and on that particular cells there is another snake and ladder, and I used it to reach another cells. So these transitions is not altogether allowed. You are allowed to do a single transitions. If from val 1 + 7s, if you identified a snake and ladder, you can use it. But on subsequent, let's suppose we reach this particular cells, so we definitely need when we are landing at a particular cell. So we have two options. If that when we have two options, when this particular cells is either holding a snake and ladder, if that particular cell is also holding a snake and ladder, then we definitely need to know if the previous jump we make using a snake or ladder used, if that jump is made using a snake and ladder, then I don't have the liberty to use a snake and ladder. If it is altogether present, then also I am not allowed to use it. But if snake or ladder used, if it is false, then I am allowed to use the snake and ladder of that particular cell. So that is the extra gist. So it is very important. It is very sorry. So it is kind of indeed important. Indeed, it is super important actually. So this one note now like crying me very badly. So it is actually very important. So please take a note this. So when we are landing to a particular cells, you can make from +1 to +7 jumps for sure. That we are allowed. So the point is when we are at a particular cells, then from that particular cells we can make a jump from cell +1 to cell +6. That we are allowed to do. But let's suppose within this jump, some has snake or some has ladder. If someone has some snake and ladder, then I will use it, and I will go to that particular cell. Then I can go to that particular cell till that it is allowed. But you have to know, because here when you are going to go to that particular cells, mark your that particular cells with snake and ladder use, kind of another variable. So you are going to get it right. So we definitely need a visit it. When we are not allowed to visit a particular cells multiple times, because for them we have already visited, we have already gone through that particular cells, all the +1 to +6 combinations. So that is not actually making sense. But we definitely need, if that particular cells we visited using a snake and ladder, snake or ladder used to visit it, snake or ladder used, that is a kind of boolean only, true or false. But we need that information. So we can't rely only just to visit if it is a visited cells or not. We don't rely on this single things only. We definitely want to know if that particular cell that we are going to jump, if it is going to be visited by using a ladder used, if we visited that particular cells with a ladder used, because if that particular cell is also holding a ladder, right, a ladder or snake, then do I have the liberty to use it? Do you have the liberty to use it? Whom you are going to question? I am going to question these variables. I am going to question these variables. If it is true, so that means I have came to this particular cells using a snake and ladder. So I don't have the liberty to use another snake and ladder. But if it is false on the else block, if it is false, then I am allowed to use it. I am allowed to use it. So that's the reason when we are coming to a particular cells, we definitely need if that particular cells that we have reached, if that has visited using a snake and ladder or not. So that booleans we definitely need. I think I am able to explain, but if not, then I will definitely suggest you to go to rewind the video once. You will definitely get the list. So these lines actually they are trying to explain these things only, but I'm not sure how you are going to get it how clear to you, but I have tried my best to explain that particular lines. And this is the lines where the things are going to be messy altogether for this particular problems if you are not going to get it on the very first. Now return the least number of dice rolls required that we are all expecting to reach the squares of n square. If it is not possible to reach the square, then we can return a -1. Then we can return a -1 for sure. Very simple. Yes. So now we can understand one example test case. So that is the, I think, 6x6 board they have given, and here you can see we can take a jump from this to this, and we can use this snake and we can use the ladder, and then so how many move? One move here, one move to go to this 2, and from 2 we have a ladder, so we can use it because we reached the 2 not using any previous ladder, right? We reached the 2 not using any previous ladder. We are reached that particular cells by dice roll, so we are allowed to use the ladder, so you used it. So how many move? You reached 15. So on single move only here, then using the ladder you reached 15. Then from 15 you roll the dice and you can make yourself to be bite by a snake. So from 15 single dice roll, you have reached from here, then snake bite here, right? Because from 17 how we reached by dice roll? 15, 16, 17 we reached here, and from here we go here. So how we reached 13 by how many dice roll? By how many dice roll? 1 to here, and from here again dice roll here to here, right? So 13 we reached 2 dice roll. On 13 we reached 2 dice roll, and from 13 roll your dice single time, you reached 14. How we reached 14? Using dice roll. Yes, we don't use any ladder. Ladder use, no ladder used. So we reached 14 not using any ladder. So how many move till now we used? 3. And from 14 how we reached here? Not using any ladder. So we can go to 35, and from 35 make yourself to bring a put, that is a single. You need a single to reach to end the game. You done it and you reach to 36. So how many times we roll the dice? 4 times. So that's the reason the output is 4. Now you can read the entire things, but exactly the same things what we have just saw in the pictorials view, they have explained, but you can read it. So on this example test case, you can see our board is altogether very short, that is a 4x4 board. So if you are able to bring a 4 altogether, or sorry, if you are able to bring a 3 altogether, so from 1, 2, 3, 4, you are able to end the game in a minimum of single dice roll. Yes, and we have to return this. And you can see our constant is in the range of n to 20, and our board of ij is either -1 or in the range of 1 to n square. If it is -1, then there is no snake and ladder, and if it is 1 to n square, so that means there is a snake and ladder. You can use it. So I think the problem statement is going to be absolutely clear to you, and if you are following our last couple of videos, then you should be able to think on your own how actually these problems we have to solve actually. So what actually we have to think? So from that particular, our source point is constant, so we are going to start from the bottom right. So where we are going to start from the game. So if now we can go to our OneNote to build the intuitions. I think intuition should be built to your brain automatically. I am expecting after solving that many graphs problem. So we are going to start from these cells, and how we are going to move? We are going to move to depth or breadth wise. How we are going to move? Depth or breadth wise? Do I have to move to depth or do I have to move to breadth? Tell me guys, tell me. So if I am going to roll the dice, then I will definitely go to breadth wise, because on first dice rolls it can be either here or here or here or here or here or here, like this, to 1 to 6 plus 1 to plus 6 to the current value. So that means that many levels or that many neighbors I can expose by a single dice roll. So these all are my at level 1. So this is my level 0. This node is reachable from level 0, and from these levels these nodes are reachable from my level +1. Level +1, we have the liberty to reach from +1 to +6. So that is my levels. That is my second level, or that is my level 1. If I am going to consider, this is the level 0, and these all are my level 1, right? This all my level 1. And from here we have to reach everyone's will expose to +6, and those all are my level 2. Those all are my level 2. Agreeing guys? Totally agreeing? Yes, you are bound to agree that. So now tell me one thing. Now tell me one thing. So we are going to do a simple breakfast, simple BFS, right? So we are going to consuming the every node with level wise, because from first level 0 we have to who are my level 1's configurations, from level 0 who are my +1 to +6 boundary, that all are my level 6 boundary. So like this way we can standard use our own template to go to the BFS way, for every node. Now there is an issue guys. There is two things that I want to discuss. Our visited array is same that we are using for all of our submissions. If it is same, is it same? I don't think so. Not. It is not same, because the problems, the statement that they have already written, that's the reason it is not going. You are not allowed to use a single visited, because for a particular cells, if it is a particular cells and if it has a starting point of a snake or ladder, if it has a starting point of a snake and ladder, then there are opportunities, there are choices, there are two basically choices. So you have to explore this particular cells using a, and let's suppose this from this particular cells is also reachable by using a ladder or snake, So for this reach, so for this particular cells exposures, we have two options. Did we explore it using a ladder? If that is one option, or someone's maybe at its previous cells, it can jump up plus, let's suppose 5, let's suppose a dice rolls jump of 5 and it is able to explode. And another is ladder used as false. So that's the reason our simple visited is not going to be work here, because we have choices. We have two choices sure, because that's the lines we have just understood, right? So for a particular cells, if that is reachable by using a snake and ladder, and if on simultaneously if it is a starting point of a snake and ladder, then I don't have the liberty to use that snake and ladder of the second go, right? So that's the reason how I am going to take that decisions by using this variables, by using the variables. So I definitely need, when I reach to a particular cells, I definitely need a variables, ladder used. So that is a booleans I definitely need. So to get it, if that particular cells that we are line using a ladder, I am landed here or not. So that information I definitely need it. There is no compromise we can do here. Yes, and our visited also. So that's the reason our visited also. How many times a particular cells then can be visited? Then a particular cells can be visited twice times using a ladder, or not using a ladder, right? Not using a ladder. So our visited should be a 2n kind of data structure, 2n, or if I am considering it's kind of 1 to n square cell, so every cells have a visitations of twice. So whatever the data structure of visited you are following, you can't put the node only. Also put your ladder used or not. So you don't allow to put only that node. You are also need to put ladder used or not. That is also needed. That is the first change on our BFS template we have to make. The second things, they have we know our Bootstrapian's algorithm, Bootstrapian's way of writing. So it is going from how actually it is going. It is going from 1, 2, 3, 4, 5, 6, 7, 8, 9. So like this way we are going, right? So now if you are landing to a particular cells, I know I definitely need its row and column value, because with 7, with like 7, if I am going to land, if I am going to state I am at board cell number 7. So what is the value? Because I need to get the value. To get the value, we definitely need this row and column. We definitely need it. So we have to derive a formula for that. So the first things, the row number calculation is simple or not? We have n as, let's suppose anything, even or odd, anything. And if we are landing to a particular cells, this. Yes. So if I am going to number it 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I am numbered it. So if you are trying to build your row number, so row number, how you can going to get, what is the value? Just divide it with standard which divisions, integer divisions you can get it. So let's suppose our n value is on this particular case is 3. So n divided by 3 is coming out as tell me 1, right? So that means it is an odd number of rows. It is an odd number of rows. So if I am going to number it like 0, 1, 2, although it is on reverse order like 0, 1, 2. So you definitely have a now and our column number. So that is my row number. So that is the formula of my row and my column number. How my column number should be derived? My column number is nothing but 5 modulo 3. So there is changes obviously needed, but let's try to. So my column number is coming to be 2. Yes, yes. Now see how good it is to give me the actuals, and I know if it is of 0 0 0, it is of row 1 for sure, and column number is 1 comma 1. So it is giving me correct. It is giving me correct. So not correct. So column number is wrong. Column number is wrong. So for column number, row number is, you are going to get it always correct. Your column number, you know, your odd rows. If the row is odd, that means this. So as the Bootstrapians way, it is going to start from reverse. It is going to start from reverse. It is going to start from reverse. So whatever the column number you have at, minus it with n minus col. So that is because you have taken it in forward. So you have to take it on reverse. So your 1 is actually not, your 2 is actually not correct, because you consider from first the second one. You consider the from first to second one, but we need to consider the second one obviously, but from reverse. So how you can go from n minus col? So our n value is 3 minus 2. We are going to get it, our col value as 1. But if it is on forward, if our row is even, yes, then on that case your call value is just of minus 1, because your call value can be like in 1 to n terms, but our row and column is working in terms of index, and we all know our index is working from 0 to n. Our index is working from 0 to n minus 1. So you took it in correct. So you need the second one from forward. But what is it index number? It is just of minus 1 of it. Call minus equals 1. So now you have correctly identified your column number. And for your row numbers, it is simple. You have took your row number correct, but you have to take it on reverse, because we are considering going from bottom to up, because we are moving from, where from are we starting? We are starting from bottom left corner, right? On the problems they have already written. So our row number should be n minus row minus 1. Definitely n minus row is from starting from reverse, and minus 1 is from index terms. Yes, I have defined my row and column. So that's extra things you just have to incorporate to your particular cell definitions. Yes. I think one more case I have left with. Let me just quickly give you the gist of it. So it is kind of like, let me take an example. If please work on the very first command. So let's suppose I have a board. So this formula is going to fail for the like, when my row is nothing but I am going to define how I am going to define it, val by n, and call is nothing but my val modulo n. So if it is a complete integer divisions like 1 2 3 4, right, 1 2 3 4, then it is 5 6 7 8 9 10 11 12 13 14 15 16. See guys, how many like whiteboardings I am doing to explain a particular problem. Same things I have done. If I am going to show you my like pen and paper work, no, so you guys are like basically thinking. So yeah, he has actually come up with the solutions with actually intuitions building on his own. So that things I am trying to build on you individuals. So otherwise you are not going to be able to solve these kind of problems to an interview. So that is kind of a difficult problem for sure. No, so these formulas definitions you should be like come up to an interview. That is an expectations if you are going to take an interview on a top productive company. So please try to write the things in pen and paper in more and more that you can write, because with otherwise the formula definitions if you are trying to define the cell number by using the current cell, like then it is going to be a super complicated. No, when you have in minus 1, when you are out of boundary, then you have to move up. When you are out of boundary in right, then you have to move up. So this extreme like if else is going to make your code like super hazy. So that's the reason I am trying to define a generic formula. Then I am going to play my game with number from 1 to n square. If you are giving me the number from 1 to n square, I am able to define my row and call by its own with the formula. So that's the like granularity, or that's the modular way of code writing I am trying to teach you guys. Yes. So now there is a case. Let's suppose this particular cells. So my row is going to come up as a 8 double divided by 4. How much it is? It is coming out as 2. And 8 modulo 4, it is coming out as 0. So that means there is a case when I am at extreme boundary. So when I am at the very last of any cells, then my formula is not going to be work, because it is basically stating me I am at second row, but the row number is the first row only. So it is going to put my even. Then what I have to do, it is a forward go. It is going to consider it as a forward go. But here it is not a forward go, right? It is a backward go. So 8 is lying on this backward go only, right? So it is forward, then it is backward. So it is not able to read it. But if it is 7, then if you can put it 7 double divided by 4, it is coming out to be 1 only, and 7 modulo 4, it is coming out to be 3 only. Yes, this formula will work because you got it, my row as an odd, then you will trying to consider the column from reverse. But here we have already messed it out because our row is coming as an even, but it is an odd row because that is of one row. So we have to consider our column from there. So for this there is a special handling. There is a special handling. Just you have to incorporate to the above formula. If your column is if coming out as a 0, so that means it is a complete division has happened. So on that case, just down your row to be minus equals to 1, because that is the row number, because it has bumped up to its yourself a one place ahead, right? Divides its yourself with exact n value. So no row, you are on one lesser, you are on extreme, that I am agreeing, but you are one lesser, so that things you have to be taking care, you have to be taking care. And your call, can you guys tell me your call? Can you guys tell me your column? What is the column value then? I have to switch my row to be -1, and what is the column value then? What is the column value? So column is nothing but I am definitely standing to some extreme end for sure. Yes. So my row is obviously a -1, and my column value is I am standing at n. So that means some extreme nth value, right? Either 1, 2, 3, 4, or from like this way, So now how it is going to be help? Now if you can use your own formula, right? So my row is coming out as an 1, so that means it is in reverse, and from reverse, what's the formula? For reverse, column is going to be, how we are calculating our column? N minus column, right? So n is 4 and your column is already holding 4. So 4 minus 4 is 0. So you got your column value correctly. Correct. And what is my row number? Row is nothing but n minus row minus 1. The same formula I can use now. N minus row minus 1. N is 4. Row is 1. And my this is -1. So 4 minus 2 is nothing but 2. So if it is at 2, 0. 0, 1, 2. Yes. And 0, 1, 2, 3. Yes. This boy is lying at row number 2 and column number 0. Yes, my formula is working. So if it is a complete division, I just have to write these two extra lines. I have to make my row to be one lesser, so that next things is going to be compute correctly. If it is forward, then it is taking it forward. If it's reverse, then it's taking reverse based on the row is odd or even. And my column, I will put it to some extreme end, and according like row value is even or odd, it is going to compute it correctly. So that's the extra gist you have to think on this particular problem space. So that's the reasons I put it. It is not a medium for sure. It is indeed kind of a hard problems. So now we can in a very good state to understand our own BFS templates. So I will going to make our helper call for sure. What we are starting? We are starting from 1th row. So we are going to make a helper call from 1. We have initialized or visited queue current move to be default ticked of int dq 0. Everything is as it is, and I have pushed to my queue to be current value to be 1. And how we have reached it? Ladder used or not? No. I have reached that particular access without any ladder. So I have pushing it to be 1 and false, and I am marking it to be visited with same as value and false, right? Agreeing guys, totally agree. And now while lane of queue, I am basically checking how many nodes we have at. So that many nodes is actually lying to that particular level. Yes, and I am count it out, and I am writing a for loop to basically pull all the labels from that particular node, from that particular labels. I am going to pull all the nodes from that particular level. So for underscore in range nn, my val and ladder used is coming to be on these two variables by method like variable destructurings. Q.pop left I have done, val and ladder used is there. If my val is altogether target, okay, I reached. What is the current move? Return it. If my val plus 6 is greater than equals to target, okay. So that means I can roll my dice again one more time. Then I have done because I am able to reach someone with more than my target or equivalent or more than my target. So then also I have done. Then not the current move I can put it. I need one more move, one more dice roll to reach the extreme. Yes. I will be do, and I can return a current move plus 1. That is the minimum is bound to get. Else, so that means I am not by plus 6 rolls also. I am not able to reach the end. So I have to think some. I am like inside of just on start the game. So or maybe some intermediate position. So let's compute it. So I will run a for loop for each in range val plus 1 to val plus 7. So plus 7 I wrote because Python take it like exclusive. The extreme right boundary is exclusive. So it is like iterating from val plus 1 to val plus 6 on. and I am only going to consider when I have to basically check every computations when that particular cell, the particular cell value is each is not reached with, and what is the current configurations. If we reach that particular cells using a ladder, if it is not reached that particular cells using a ladder, then only I have to consider, because then only I have to consider what is the explorable things we can do. Because if it is altogether reached to a ladder altogether, then I am kind of like blub. I am not used to do anything, because so that's the reason this particular cells should be exposed using using not previously a ladders, right? So that things I am checking at, if that particular cells is exposed not using a ladders, so that means ladder used is false, then I am going to compute it. These things that is of, let me just think about this. So my compute row and calls, I will make a calls to that compute row and call functions. Yes, I'm going to make a calls to that compute row and calls, and it is doing the same things that we have just written to our OneNote. It will going to take a value, and it is compute my row and calls with value integer divisions, value modular divisions. If column is coming to be a 0, then decrease your row to be -1 and set your columns to be n. Then other things will going to be taking care. If you are going to set it to this, then it is going to take it forward or backward. If it is forward, sorry, if it is backward, if it is odd, then it is a backward. So you have considered your call to be n-1. If it is forward, then consider in kind of index terms. So do a -1, because index is always lying from 0 terms. Index is always start from 0, not from 1. And my row, I have considered it from bottom to top, but row is going to start from 0. That is the top row is who is on the top row. It is on the first row. It is on the first row. So row also I have its reverse. So on reverse I will do n minus row and index terms -1, and I am going to return my row and call. So far, if you are going to get me any value, any dimension, any n cross n cells, I am able to define its row and column using this compute row and call functions. Like this way, guys, you have to write the things to your interview. Try to granularize the things to a functions, and if it is reusable for across all the ends, well, then you are on very good state to define it. So I find my row and call well by making a call to compute row and call functions. Yes, I did it. Then I will going to check if, then I am going to mark my visited of each and false to be 1. Because why it is visited of each and false, because from that particular node, so that is my node value. So from node value I am reaching this particular cells, so that is actually my neighbor, right guys? So on our general template is this each is actually my neighbor, because from that particular cells I am rolling some dice from 1 to 6 and I am trying to reach my neighbors. So that is my next guys. So how I have reached that particular cells every time, using dice only, not using any ladder. So that's the reasons I am checking if my each and tails. So that means this particular cells has reached using a dice roll only. So from parent is val. So from parent, that is my val, I reached my neighbor. So my neighbor is each. How we reached using dice only, because this for loop is iterating for dice rollation only. Yes, agreeing, totally agreeing guys. So that's the reason I am checking if my visited of my neighbor, how we are visiting, not using dice, not using ladder used, by using dice only. So ladder used is false. If it is so, then I am going to compute it. I am marking that particular visited of each and false to be 1. And now I am going to check what is the value this particular board is holding. So I am storing it to kind of ng variables, that is a neighbor for my case. So if that board of row comma call is coming out to be a target, so that means I can able to reach my neighbor. I am able to reach my neighbor by a single dice rolls. And what is the dice rolls? That is of +1 to +6. I am rolling the dice, and that is my target. I have defined my target initially, that is of n cross n, that is of n squared. So that is my target. And if it is equivalent to my target, okay bro, you have done. So you can return the entire things from current move +1, the same things that we have done here. If this things is reachable from within the +6 boundary, if I am able to reach my target to within the +6 dice roll, then I can return to current move +1. Again, a similar guy. My neighbor is altogether a target. Yes, then I can reach it with current move +1. So you can see my neighbor, how we have defined what is the value it is holding. So that means it is actually holding some snake and ladder used on that particular cell also, right? Because if that particular cell is holding some value, then using that value may be my end of the game. Because on that particular cells, by using a dice, we are land to a particular cells, and on that particular cells, we used a dice and ladder, and my neighbor is coming to our target. So that means of n squared cells. Then I can write it with a single dice. I roll the dice, and I am super lucky. I am got a ladder of snake, mostly ladder only, not snake. So I got a ladder, and the ladder is basically ending me to to the extreme my target cell, to my target cell, and I can write it. So a single dice rows, I can reach to my target to a single dice row. So I can return from current move plus 1. Yes, if now the case, if my neighbor is not equals to -1, if it is not a target altogether, and if it is not a -1, so that means I have to go to some cells. I have to go to some cells. Now this go is using some ladder and snake, right? This go is using some ladder and snake because my neighbor is not a -1. My neighbor is not a -1. So that means the go that we are trying to explore, that is using some snake and ladder. So I have to check my visited of neighbor now true because I am reaching here using some snake and ladder. If it is using some snake and ladder, this particular cells is not exposed, then I am allowing to expose it. So I am going there, queue of append to neighbor and true. So that Boolean is actually walking me that particular cell. When I am there, I am going to know if that particular cell is exposed by using already as neighbor and cell, by using already a ladder used, by using already a ladder used. If that is so, then I am not allowed to do so. So here you can see, right? If that particular cells again try to use some ladder and snake, then this particular variable is never going to be true, and we are never pushing some things to our queue for sure. But if it is, and as we all know, this particular each is exposed by not using a ladder, right? So if that is so, then I am using to push it to from this particular cells. I reached a particular cells using some snake and ladder. Yes. So I am pushing it queue.append to my neighbor and true, and I am marking it or visited to be neighbor and true only. And if it is like a kind of simple jump, like if it is there is no snake and ladder, I am going to push my queue to be simple each and false. So I reach that particular cells using dice only. So I am pushing it to each and that particular. So neighbor is my each, and that particular cell is reached, not using any snake and ladder. Yes, that particular things we just have to incorporate. And after this for loop executions, my current move count or my current level is bound to increase. That is in our template, that is in our BFS template. So it did it. My current move plus equals to 1. Yes guys, totally agree. And after this entire things, if we are not able to return our functions to at any particular times, if we are not able to return our functions, not a single returns has executed, so that means our queue is empty. So that means we don't have to explore anyone's, and I am not able to hit my target. So am I in good state to return a -1? Yes, you can. So return a -1 from, and from this finally we are returning whatever the helper is returned us. If it is -1, so not possible. It is straightforward return. -1 we are returning, or if it's a value return, then also we are returning it as it is. Yes guys, so the problem is I don't have to say is as simple as that, but on implementation perspective it is kind of indeed in grip for sure. But if you have correctly understand or done your own whiteboarding to compute your row and calls correctly, apart from that, if you are like taking the node to exposing your neighbors with every node have two possibility. Either it has exposed using a snake and ladder, or it has a dice roll you have reached it. So these two things you have to be taking care. So a particular cells has two options to reach it, either via snake and ladder or via dice roll. So ladder used for every cells, you definitely need a ladder used or not, this booleans for sure. Yes. So that's it guys for this particular problems. Now if I am going to quickly discuss the time complexity, I think you guys should be aware of this. So on time complexity, how many times we are visiting every node, how many times we are going to visit every node? It is twice, right? Either by using a snake and ladder, by using ladder used, by using this variables ladder used as true, or maybe the variables ladder used as false. So it is kind of 2, and how many cells we have at n squared cells. So it is kind of big of 2n squared, right? And on space complexity, what is the space complexity? We are only using the visited, only, and the queue also. So these two can hold every node value at max twice. So queue can hold at max twice every value. So how many values we have? 2n squared, and visited also can hold at max of twice n squared. So it is kind of big of 4n squared, right? 4n squared for sure, not more than that. So in terms of, if I am going to write it in big O, it is kind of like big of n squared, and this is kind of big of n squared only. Yes. In big O terms, it is of big of n squared, and big of time also big of n squared, and space also on big of n squared. And you can see our n value is super small, that is of 20. So we are doing our entire things in very less times, and it is bound to be the most optimal time and space complexity you can achieve for this particular problems. And you can see my submissions. It is kind of like 91% faster than all the submissions over the Leetcode. So I'm not able to see it, but here you can see. So it is kind of like indeed a optimized runtime solutions for sure. And on memory also, like I feel so it is the minimum memory you can achieve, but maybe they have try to do like use the same queue and visit it on a single purpose, but I don't like it at all. So I definitely for every problems I like it to play my entire games to the visited, and my queue is basically do the BFS on. And if I am able to explore to a particular sales or not, if it is already visited or not, so I definitely like prefer to use a different value. So it is kind of big of 4n squared, but I am happy to take that hit because my code is super readable on that particular place, rather than like dirtifying everything to a single variables to optimize my space. So that is indeed the most optimized runtime and space you can achieve for this particular problems in the more granular and modular versions of writing the code. And if I know like explaining this particular problems is kind of understanding this particular problems is definitely super complex. Like if so these particular lines altogether that we did in our OneNote explanations, and if you guys are able to do so, I tried my best to explain to you guys, and if you guys are able to do so, so please do subscribe to the channel. Please share the videos to your friend circle who are also preparing for top product based company and brushing up their DSS skills, and please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible, guys. So that's it, guys. That's it for today. Let's meet tomorrow with another video question. Bye, guys. Bye.